Okay, the final question that I have at the moment, and then we'll see if anybody else has anything else before we finish, is another technical one for Bob. So the 6 amp BSEN 60898 type B circuit breaker protection for a lighting circuit that I recently worked on keeps tripping off when the lighting is switched on. I have tested the insulation resistance of the circuit conductors L to N and L to E and N to E, but the circuit and LED lights that I installed appear to be satisfactory. What could be causing the circuit breaker to trip?
Okay, well, fun enough, I had a similar technical question last week from a chap who phoned, and he'd spent quite a bit of his morning disconnecting and disassembling a lighting circuit and carrying out similar tests. A complete waste of time. I had to say to him, it's a fairly well-known problem with LED lighting. You have high inrush currents, and it's an area, again, probably we should get some sort of technical information to our members. So I know the ECA also have been looking at this. So again, maybe an action on me to draft some for our members on this. When you're installing, obviously, LED lighting, the sales pitch would be that for the customer, you're getting improved light output, increased lifespan, reduced maintenance costs, etc. So there's a lot of advantages to installing LED lighting, whether it be lamps or specific luminaires. However, depending on the make and the number of these lamps or luminaires that you're installing, the existing circuit arrangements may not be suitable for the inrush current that goes hand in hand with LED lighting. Just to make sure everybody's clear, inrush current isn't the same as the normal running current of a lamp. It's a current that kind of happens, a transient current that appears for a fraction of a second. The inrush current, the information I've obtained actually on this from the ECA, from Schneider Electric specifically, the inrush current can be quite significant. I've been looking at another publication, the IET Code of Practice on this, and they were talking about an inrush current of anything between 10 to 50 times the rating, the rated current of the lamp. In actual fact, Schneider are saying that it could be up to 253 times the rated current of the lamp. So if you were looking at, for an example, a 10-watt lamp, the normal current for a 10-watt lamp would be about 43 milliamps. 253 times that, you're suddenly looking at 11 amps, the inrush for a single lamp. So there is also another problem associated with that. If you've got a significant number of LED lamps installed, they can actually cause damage to the switches within the installation, i.e. the switching terminals, and they can result in premature failure. Not only that, I suppose if you're putting these in commercial properties, you may be switching through relays and such like, and you've got the same issue there, you could end up damaging relays. So there are significant considerations when you're retrofitting or installing LED lamps or luminaires. Remember, an LED is a light emitting diode. It's a semiconductor device, and they operate on DC currents. They don't operate on AC currents. And they need to operate, they need to have a control gear, usually known as a driver, and that provides a constant current for the lamps to illuminate. But the downside of that is it causes a capacitive effect on the input circuits, which causes this high inrush current. Now, those of you who've done our update training on inspection and testing will be aware of this bit. This characteristic of our modern circuit breakers, your BSEN 60898 circuit breakers, what do they come in? They come in a range of sensitivities. They've got a range of tripping characteristics. You'll all have heard of type B circuit breakers and type C circuit breakers and type D circuit breakers. Now, they're recommended for certain uses. If you're using a type B, for instance, they're recommended for general use, where no inrush currents exist. So if you've got LED lighting that you've just installed, they're not really suitable for type B circuit breakers. You may prefer a type C circuit breaker. A type C circuit breaker allows for an inrush current, and they're recommended for use with electric motors. So they've got an inbuilt allowance for motors to start up. You usually you've got the same thing with LED lighting, and if you go very high inrush loads, big motors, transformers, welding plant, that sort of thing, you might be looking at type D. So in this instance, where the lighting circuit's protected by a 6 amp type B circuit breaker, the tripping characteristics determined by the product standard, the BSEN 60898 standard, they tell you that it will operate in a time greater than 0.1 of a second if you've got 3 times the rate in the circuit breaker. So if you've got 18 amps of current flowing for a duration, a short duration, the circuit breaker will trip slightly over 0.1 of a second. If you've got anything greater than 5 times the rate, so for a 6 amp breaker, 30 amps, it will trip instantly in less than 0.1 of a second. Type C's have got an inbuilt allowance for that. They take 10 times the rating of the circuit breaker to operate. So a 6 amp, you look at something like 60 amps before it would start to operate. So you can see that could be a problem. You know, if you are installing, say, 10 watt lamps or LED lamps with a single lighting circuit, you know, if we were looking at maybe a particular make, because the makes and the inrush will vary, you could have, say, a make where you've got 50 times the rating of the lamp current. This would result in an inrush current of something like 21.7 amps. So clearly it would trip a 6 amp type B circuit breaker. So the solution for this, as I say, not to waste your time doing earth leakage tests and insulation resistance testing, the actual solution is stand back, have a wee think about it. It might be that you need to upgrade the circuit breaker and put in a type C breaker, or alternatively, have a think about the number of LED lamps or luminaires that you're installing on that particular circuit. Again, I would point out in the domestic building services compliance guide for Scotland, which gives you compliance for the energy requirements of the building standards technical handbooks, the advice is no more than 6 light fittings should be controlled by 1 light switch, and a maximum of 100 circuit watts. So there you go. There, if you think of, I was just thinking about the last time I installed these lights, I put some in the living room, 8 10 watt lamps. Suddenly I'm just about, you know, in the limit there. The good thing is many lamp manufacturers are now providing information on request regarding the number of lamps that you can connect to a lighting circuit, and also they'll give you advice on the circuit breaker that might be required. There's also some good information I mentioned on the IET code of practice for the application of LED lighting systems, and the likes of Schneider and Thorlux Lighting in particular are very good at providing information. So, as I say, I think I'll put together some sort of technical circular on this, because it is an issue in the industry. I know BEMA, the Equipment Manufacturers Association, are also looking at this and trying to produce maybe some guidance on it. So that's what we'll do for members. We'll get together and get a circular technical update out along with some associated information. I think I've got some I can also paste there. There's one there on the rating for LED luminaires. I'll send that to you guys. And also I've got a few others. I'll dig them out and attach them to this list. Okay. Again, another long-winded answer, but there never is a short one.
Thanks, Bob. Okay, any questions for Bob around that? No? Okay. I see that Neil has put a question on the chat around apprentices.
Yeah, so No, I was just going to say we'll not read it out just because of the situation we're here where this is recorded and being in a public domain in a moment. I think with this situation, it's best, Neil, if we catch up offline, and we'll just discuss this matter separately, if that's all right.
And can I add, Neil, if you need any information about the training and what he needs to complete, if you'd like to come back to me direct, I've given you my email address and my mobile number.
Okay. Okay. Thanks very much then. Okay, so that was the last question that we had. Does anybody else have anything to ask any of the panel or Anne while we've got her with us?
No, thanks. That's
That okay?
enough. Yes, thanks.
Okay, well, all I've left to say is thanks everybody for joining us this evening. Hope you found it useful and informative. And you can all now go out and enjoy the rest of the sunshine, enjoy your evenings. So thanks very much for joining us.
Thanks, guys. Bye.
Thank
Thanks,
you.
everyone.
Bye.
Bye.
Thanks very much, everybody. Take care.
Thanks, Anne. Bye.
Bye-bye.
Right.